Solar motor. This is the village of Austin, Nevada, in the United States, population 192. Do they have solar heat to spare? Yes, they are in the middle of the Great Basin Desert. The solar motor operates like a conventional steam engine. Fuel is burned to heat water. At about 212 degrees Fahrenheit, the water boils into steam, creating high vapor pressure. This pressure may be used to drive a piston within a cylinder or to drive a fluid turbine. The pressure may be used to drive a piston within a cylinder. The piston powers a crank, which converts the reciprocating motion of the piston to rotary motion of a shaft, which powers an electric generator. Or the pressure may be used to drive a fluid turbine, which then drives an electric generator. In both cases, piston or turbine, the steam is collected, cooled, condensed back into liquid water, and recycled or boiled once again. You say it's like a steam engine, and you call it a solar motor. Why? Because instead of water, it can use any of several working fluids that will boil from sunlight alone. No other fuel, fossil, biomass, or nuclear, is needed to produce the vaporization or boiling. This means no combustion, no fumes, no pollution, no carbon dioxide, low noise, and no fuel cost. Its working fluid is completely recycled. Its fuel source, the sun, is most abundant midday, when demand for electricity is often highest. Instead of water, which boils at about 212 degrees Fahrenheit, it can use any of several working fluids that will boil from sunlight alone. Ether, 95 degrees, acetone, 133 degrees, and methanol, 151 degrees, would be good choices. But aren't they all highly flammable? Yes and no. Ether is interesting. It is sold right off the shelf in your big box retailer as engine starting fluid. Diethyl ether, highly volatile and flammable, is often the primary and sometimes the only ingredient. Acetone is sold as paint thinner in thin, flimsy metal 1-gallon cans at your local home improvement store, but they don't expect it to vaporize or boil. Butane is especially interesting. A hydrocarbon, like methane, ethane, and propane, it is sold in pressurized sealed containers with a built-in ignition device about 3 for $1. Yes, hard to believe. As soon as it is released, it instantly vaporizes and ignites. Think of that. A pressurized, highly volatile, highly flammable substance like gasoline sold for consumer use without regulation, there are no limits and children can buy it, with an ignition device directly attached to it for less than $1. In fact, you probably have several of these in your own home right now. They are butane lighters made popular by Bic. 6 million of these are sold worldwide every day. Since introduced almost 50 years ago, 30 billion have been sold worldwide in 160 countries, with an accident rate very close to zero. Isopropyl, or rubbing alcohol, is also interesting. It has a relatively low vapor pressure and is not generally considered either highly explosive or dangerous, but it vaporizes or boils at only 177 degrees Fahrenheit. It is typically sold with no warning labels. Okay, maybe these could be used safely, but you say you can boil it using sunlight alone? How do you know? I've already done it. So can you. If it's summer where you live, try leaving a piece of black sheet metal out in the midday sun and checking its temperature. Below, the ambient temperature was in the low 90s Fahrenheit, but the flat black metal plate showed a temperature of 166 degrees. Here we have a Corvette, a kind of classical American sports car. This one is black. It's parked in a parking lot, and the ambient temperature is 92 degrees Fahrenheit in the shade. The temperature on the roof of the car was 185 degrees Fahrenheit. This is more than enough to boil or vaporize any of the fluids you see in this chart. James Watt of Scotland is widely credited with developing the steam engine, which burns coal to boil water to produce high-pressure steam to power a piston. 250 years later, this is the same basic process behind most commercial electrical generation today, except that steam turbines have generally replaced pistons and cylinders. The solar motor that is the subject of the current invention is similar, with two major exceptions. Instead of burning coal, it uses the sun, and instead of boiling water, it boils either ether, acetone, or methanol to produce high-pressure steam or vapor to power a piston or a turbine. Again, it uses the sun to boil ether, acetone, or methanol to produce high-pressure vapor to power a piston or a turbine. In many places, such as my home in South Carolina, attic heat alone is often sufficient to boil ether, acetone, or methanol. I could generate electricity in my attic and store it in my Tesla Powerwall if I had one. After the hot vapor passes through the turbine, it cools and condenses in conduit buried in the ground, ready to be recycled. If the tank below were painted flat black or dark blue to absorb the rays of the South Carolina sun, and then filled with ether, acetone, or methanol, how much fluid pressure would be available to power turbines? I stare at this picture. It's a thing of beauty. I say it's an inventor's Mona Lisa. I hasten to add that this example is extremely dangerous. Fortunately, pressure relief valves are old, reliable, widely available, and cheap, so multiple redundant pressure relief valves would be installed to prevent what otherwise would be a powerful explosion. This will generate electricity in the desert. Here's a picture I took of that village of Austin, Nevada, population 192, several years ago. They are completely surrounded by many miles of hot desert. The working fluid can heat in direct sunlight, and the vaporized working fluid can cool and condense in the shade, barrels of water, or in the ground. If the tank were painted flat black or blue, advertising space could be sold on it. The power produced may be used to pump water. Here are a few potential customers. The solar motor described here is the subject of a pending U.S. patent. John Saavedra, the CEO of Look for the Power LLC, seeks a forward-thinking research university to lead the basic research and development needed for humanitarian deployment and commercialization. If interested, or if you know of someone who would be, please contact John at lookforthepower.com. Details and more at lookforthepower.com. Thank you.